All right, slope. That's what we're working on today. Let's go. So everybody's favorite slope is always a roller coaster. Let's see if I can get this to actually play. Come on. Oh, I was gonna tell you, Betty. Oh, hey, there we go. Oh, well, that one goes forward, then backwards. Oh, we're going backwards on a roller coaster. Oh my goodness. And now back forward. Yeah, this is a lot of slopes here. Back up. Oh man, that is a scary start to a roller coaster. Going down. The slope's going down. All right, we got the point. So, slope describes the steepness of a line. It is the ratio of the rise of or vertical change to the run of the horizontal change. So you'll hear me say this a lot. Slope is rise over run. Say it a lot. So vertical change over horizontal change. So the rise would be here, the run would be here. You can sometimes just, if they actually give you the line, you can just count it out. So it'd be 1, 2, 3 over by 3. So rise of 3 over 3. So this would be a slope of 1. Okay, so the slope of the slope m is usually listed as m, passing through the points x1, y1, and x2, y2 is the ratio of the difference of the y coordinates corresponding difference of the x coordinates. So here is the slope formula. So m is y2 minus y1, x2 minus x1. Notice it says 2 over and minus 1. And it actually doesn't matter which point you pick as long as you keep them in the same order, because you don't want to subtract y2 or x2 when y is there. So I'm going to make you rattle a lot on this one. Sorry, guys. So x1, y1, x2, y2. Doesn't matter, again, which one, but you just got to make sure you put them in the right order. So x2, y, x point, y, or 1, 2. Or 2, 1. Either way, just make sure you keep those in order and you'll be fine. All right, find the slope of a hill that rises 30 feet for every horizontal change of 150 feet. So I would do, the definition of slope is rise over run. And they actually said rise and then horizontal change. So I can just kind of match those in. I'm going to put in rise of 30 feet over a run of 50 feet. So that could be my slope, but we can probably reduce those numbers there. So that would simplify down to 1 over 5 would be my slope. So the slope of the hill is 1 over 5 or 0.2. Most of the time we're going to use a slope of a fraction. I know you're going to hate that, but it'll make more sense later. Especially for graphing, because if you're graphing, your rise is going to be 1, your run is going to be 5 units. So that's why we tend to use fraction most of the time when it comes to talking about slope. Keeping going. All right, find the slope of a hill that rises 40 for every horizontal change of 100 feet. Go. Okay, so I have to do rise over run. Wow, my U and N's both look the same. That's terrible. So rise of 40 feet and a run of 100. That can reduce down to 4 over 10, which can go to 2 over 5. So 2 over 5 would be my slope. Moving on. So find the slope of this line. This is where that slope formula comes in. So we're going to use the definition of our slope. We're then going to label it out. And I'm going to make you write this every time. x1, y1, x2, y2, 0, 1, 1, 4. So now I'm substituting them in. So y2 goes for y2. y1 goes for y1. x1 goes here, and x2 goes here. So you substitute those in. Now we do the equation. 4 minus 1 is 3. 1 minus 0 is 0. Gives me 3 over 1, which reduces to 3. So the slope is 3. The other thing you could have done on this is you could have counted up. Rise of 1, 2, 3 with a run of 1. It's another way to do it. But the guaranteed way, they may not give you the graph every time. So the guaranteed way is to use the slope formula. Your turn, go. All right, so I got my x1, or sorry, it's y2 minus y1 over x2 minus x1. So I'm going to take my points. I'm going to say x1 and y1 are going to be the top one. Why not? So that gives me 1 comma 4. And my x2 and y2 are going to be -2 and -3. So x1 goes here, so it's going to be 1. x2 is first, so -2 minus, and then y1 is 4, and -3 is y2. So -3 minus 4 equals -7, and -2 over this is -3, which will come out to because negative over negative is going to be positive, equals 7 over 3. And that makes sense because this is going a positive number. I could actually have counted 1, 2, 3 over 1, 2, 3, 4, 5, 6, 7. Would have given me 7 over 3 as well. Find the slope of this line. So we're going to use that slope formula again. Definition of the slope. We're going to label them out. Make sure we know which one's which. Put them into our equation. -3 minus 1, -3 minus 3, gives me a 2 over -6, or a -1/3. So the slope is -1/3. Your turn. Find the slope of this line. Go. All right, so my x1, y1, I'm going to choose as, let's do this one this time. So I'm going to go 5 and -1, and my x2 and y2 is going to be -2 and 4. Okay, so putting those into here, so x1 is 5, x2 is -2, and then y2 is 4, y1 is -1. So for minus of -1 will be a positive, will be plus, so 5 over, looks like -7, so that'd be a -5 over 7. It's a negative direction line. I could also count 1, 2, 3, 4, 5, 6, 7, and count up 1, 2, 3, 4, 5. Also, we've done the same thing. Find the slope of this line, a straight line. It's a trick question. So the definition of a slope, we put all the numbers in. I'm going to speed through this just a little bit. That's going to come out with a 0 on top. If the 0 is on top, your slope is 0. So the slope would be 0. So the slope of a horizontal line is 0. So find the slope of this line. Go. Okay, to save time, you could write this all out. I'm okay with that. But we all can see y2 and y1. So y2 minus y1 equals 0 over something. Will equal 0. So therefore, the slope is 0. Find the slope of a vertical line. Okay, so when we put this one into our, all right, so x1, y1, so you're taking the lower number here, or the lower one, the upper one's here, 2, 3, we put that into our slope. Yeah, so if we put that, they actually should have done it. So I'm actually going to do it. So I'd have -2, or sorry, yeah, 3 minus a -2 over 2 minus 2 equals 5 over 0. You can't have a 0 in the denominator in a fraction. That's not a fraction. So therefore, it's not a slope either. So we call this an undefined slope. So in your homework, you can just write undefined, or m equals equals undefined. So the slope is undefined. There we go. Your turn. Try it. Go. So in this case, I'm just going to speed through this again. So 3. So let's go -2 minus 4, -2 minus 4, and then -3 minus a -3 comes out to -6/0. Can't do it. Slope is undefined. All right, so you might get something like this. Hey, I'm doing all right on time. 2 highway routes connect city A and city B. The first route rises 4 yards vertically for every 30 miles, so 4/30. And the second route is 8 yards vertically for every 70 miles, so 8. 8 is rise, run is 70. Which statement is true? The first route is steeper than the second, and you can just read all those. All right, so we need to compare the routes, so we need to find the slope of each one. I kind of already did that. So the first route is going to be rise over run. So it was 4 yards over 30 miles. So we can convert that into all yards. So about 0.00076. And the second route, you're going to use your calculator for that, by the way. Rise over run, 8 yards over 70 miles. 70 miles would be 5,280. Or let's say miles to yards. Multiply that out. And we divide those together. Lots of calculator work. So 0.76 is bigger than 0.00065. So the first route is steeper than the second route. Answer is A. And you may have actually been able to figure that out. No, because these are not close enough together. You know, I could have like doubled this and gone like 8/60 to get it close to the same denominator. But still probably better do it this way. I don't think you're going to see a problem like this on your homework, but just in case you see one on the test, make sure you know how to do this. All right, see you in class.